Alright, so now problem 17 on the exam 2 correction. Find the maximum volume of an open top box with a square base if you have 1200 centimeters squared of material, but the bottom needs 4 layers for support, meaning you need 4 bottom squares. So what we're going to have to do here first is label our objective and our constraint. So we pretty much already know we're looking for the volume of this cube. And so that's simply going to be x squared times y. Now our objective is to maximize our x squared times y. And our constraint, since they only gave us 1200 centimeters of material, is going to be 1200 centimeters squared over x times y. But we can get rid of that centimeter squared so it doesn't confuse us with the other variables. So since we have 4x squared plus 4xy, because our x squared is this, and since we have 4 layers, that's where the 4 comes from, and our xy is going to be these x's times this y as well, so that's where that comes from. And so what we're going to want to do first is try and solve this constraint for y so that we can take this y and plug it in to our volume equation. And that'll allow us to solve and get a max in a minute. So where we go from here is we subtract the 4x squared over to the 1200 over xy. So it's going to be 1200 minus x squared minus 4x squared over xy. Then we can just divide by this 4x and swing it over here, and it's going to be this. So we're going to have y equals 1200 minus 4x squared over 4x. And we can simplify that to y equals 300 over x minus x. And since we now have a y, we can plug this y into our volume equation. So it's going to be v equals, or basically right here, our v is going to equal x squared. We put it over 1 so this is a fraction, makes it a little easier, times 300 over x minus x. And this becomes just 300x squared over x minus x cubed, because we had to distribute that x to everything since it was multiplied. So then we can simplify, take this x and get rid of that square, and it's just v equals 300x minus x to the x cubed, excuse me. So then we can set that equal to 0 in order to obtain a x value to get a max or min, depending on how it plays out. So we set it equal to 0, subtract the 300 over, subtract the 3 over, and that gives us x squared equals 100. So we take the square root of that, and it gives us x equals 100, or x equals 10, excuse me. So now that we have an x value, we can take this and make a chart with it to determine if that is a maximum or a minimum. So here's our x values. First, we start out with 0 because that's like nothing. That's like, I believe that's only just walls and no base. So of course that equals 0. Then we can take our value 10 that we got, plug that in for every x, and it gives us 2000. Now you can probably already see we found that that was a max, but continuing on, like we don't know that, our next value will be 300, the square root of 300. Because if we had just solved originally a little bit differently, we would have 4x squared equals 1200, divide by 4 on each side, and that gives us x squared equals 300, or x equals the square root of 300. So we plug that in for x, and of course that gives us 0. So that means that 10 is our maximum, and that is the answer for this problem.